2 to the m plus 2 to the n equal to 2080, and we want to find m and n. M and n are integers. So here, at first, I consider if m and n are positive, equal 1, then without loss of generality, we consider m is greater than equal, and because it is symmetric, the equation in terms of m and n. So m equal to n plus k. So because 2 to the m plus 2 to the n is 2080, I replace m with n plus k, and k is at least 0 and it's integer. So I conclude 2 to the n plus k plus 2 to the n equal to 28. Now I want to use power rule. Power rule is what? A to the m plus n equal to a to the m times a to the n. So I can conclude 2 to the n times 2 to the k is 2 to the n plus k plus 2 to the n equal to 28. Now, we factor from 2 to the n, it will be 2 to the k plus 1 equal to 28. Now I should factorize 28. It will be, let's see, 2, 0 is, I can say it's 208 times 10. And 208, you can say it's 4 times 52. And 10 is 2 times 5. And next step, 52 is 4 times 13. Let's check. Okay, times 2 times 5. It will be 4 times 4, 16 times 2, 32 times 65. 32 is 2 to the n, 2 to the k plus minus 65 because output and power of 2. So 2 to the n equal to 32. 2 to the k plus 1 equal to 65. If we subtract 1 from both sides, 2 to the k equal to 64, which is 2 to the 6, so k equal to 6. And 35 is 2, 32 is 2 to the 5, so n is 5. Now, here we know m is n plus k. So m is n plus k, which is 5 plus 6, which is 11. So, we found this case. M is 11, N is 5, and because we said without loss of generality, you can switch the answer. M is 5, N is 11. We found these two answers for the case that both of them are positive. Now, let's check the case that, for example, both of them are not positive. So, one of them is 0 or negative number. So, let's consider case 2. For example, one of them is 0. If both of them are less than 0, let's check this case first. Then 2 to the m plus 2 to the n. We know it's 2080. Problem says, but 2 to the m is less than 2 to the 0. Or let's say if both of them less than or equal. Less than or equal 2 to the 0, 2 to the n less than or equal 2 to the 0. So 2 to the m plus 2 to the n less than or equal 2 to the 0 is 1, it's 1. But we know it's 2080 and it's contrary. Now, in third case, we've considered both of them less than or equal 0, and also we've considered the case both of them greater than equal 1. So we should consider the case that one of them greater than equal 1 without loss of generality, suppose greater than equal 1 and n less than or equal 0. In this case, let's consider case 3 1 first. M is at least 1, n is less than 0. Then 2 to the m is integer. Because n is negative, 2 to the n is not integer because it's 1 over 2 or 1 over 4. And 2 to the n plus 2 to the n is not integer. But we know 2 to the n plus 2 to the n equal to 28. 2080 is not integer. That's a contradiction. 2080 is integer. Let's consider case 3 2. M is at least 1 and equal to 0. So in this case, we can say 2 to the m plus 2 to the n equal 2 to the m plus 2 to the 0, which is 2 to the m plus 1. You know, 2 to the m plus 2 to the n equal to 28. So we can say it's 2080. 2 to the m will be, if you subtract by 1, 79, but we know m is at least 1, but it should be even. It's not even, it's odd. Okay, so we've solved this problem, and our only answers are 11, 5, and 5, 11. If you want more problems or more ideas, you can send a message to my WhatsApp number, and please don't forget to subscribe, turn on notification, and like the video. Thanks. See you next time. Bye bye.